Bismillahirrahmanirrahim. So our project name is Design of Reconfigurable Direct Digital Synthesizer using FPGA System on Chip. So my name is Zafa Yasir and my group members are Muhammad Tahir and Muhammad Ahmad. So our supervisor is Dr. Muhammad Awais and our internals are Engineer Ali Ruman and Engineer Kamran Fayaz. So these are the contents for our project that I have made the slides. So let's go. So introduction. What is the motivation behind our project? So DDS is a technique to generate analog RF frequency using all digital techniques. DDS is an important component of software-defined radios. In contrast to analog components, DDS relies on digital components. Analog components have fixed parameter, means resistor, inductors, and capacitor, and have non-linearity. Digital system is based on CMOS technology and is programmable by software tuning. So our objectives are understand the complete design flow of a system on chip design and embedded application of practical complexity. Get expertise in RTL, Verilog, design of an application from software defined radio domain, learn how to perform hardware software co-design and embedded application. So investigation behind this. DDS is a method producing an analog waveform using usually a sine wave by generating a time varying signal in digital form and then performing a digital to analog conversion. Because operations with a DDS device is primarily digital, it can offer fast switching between output frequencies, fine frequency resolution, and operation over a broad spectrum of frequencies. With advance in design and process technology, today DDS devices are very compact and draw little power. So this is the general DDS architecture. This is the digital signal. We have some algorithms of the sine wave. Usually we used four wave sine, cosine, rectangular, and sawtooth. So digital to analog converter is there for the digital to analog conversion. So this is an example of DDS. DDS may be used as a signal generator. This is the typical forms of DDS device, and this is the basically system on chip. System on chip have basically two things: an FPGA and a microprocessor. FPGA is reconfigurable, and microprocessor can be accessed software that is user friendly, and user can access through software and entertain the FPGA. So this is the picture of our total system on chip. There is a processing system and programmable logic. So working steps. There are several working steps of these projects. First of all, we have generated the waves sine, cosine, rectangular, and sawtooth on MATLAB and stored in a file and stored the samples in a file, 4 KB memory for each. Then we have designed the ROM module in Verilog. Then we have the mux for selecting one of the wave, and then there is a counter module that will provide the address to the ROM and select specific ROM, and there is a DDS module design and implementation. There is a complete design that we have implemented for selecting waves on the basis of counter address, and there are force button for selecting each waves. Then we have implemented on this on FPGA, and FPGA produces some digital signals. Then we have attached these digital signals to DAC, that is a digital to analog converter, that gave us the analog waveforms. So this is the project management of our individual contribution of each of the group member. Hamad Ahmad designed the data path, and myself, Zafa Yasir, designed the RTL coding. Muhammad Tahir designed the hardware, especially digital to analog converter. And our group work is to perform as a group that hardware, software, co-simulation and integration. So this is the project timeline. for the 2 semesters that we have done and designed in this way. And these are the development tools: MATLAB for generating signals, and Xilinx AMD Vivado design suite for a software where we have implemented the design, the coding, Verilog coding. And there is a kit, Xilinx AMD standard development kit, and we have used the Virtex FPGA board, especially Virtex 7 we have used. And these are the social impacts and SDGs. Especially it works on industry innovation. There is a flexibility of a components and communication system on FPGA based design flow. And thank you, this is the end of our video.